we're going to begin our very last lesson of chapter 1, which is solving rational inequalities. All right, so to solve a rational inequality, we're going to get 0 on one side of the inequality, get one singular fraction on the other side, and then we're going to set the top and the bottom equal to 0. All right, now we're going to use those values, just like we did in the previous lesson. We're going to use those values as our key points to separate our number line into sections, and then we're going to use test points, just like we did with quadratic inequalities. All right, so let's start. I'm actually going to start with number 2. Right, that one's actually a little bit simpler to start with. So number 2 actually has everything that we need, right? I have a fraction, a single fraction, and then I have 0 on the other side. When we have this, I can set the top equal to 0, and I can set the bottom equal to 0. So I'm going to get x plus 1 equals 0, and x minus 4 equals 0. So then I get x equals negative 1, and x equals 4. All right. Just like in the previous lesson, I'm going to use these as test points. So I'm going to have a negative 1 over here and a 4 over here. All right. I'm going to pick a point to use. All right. In this case, again, the easiest one to pick is 0. So I'm going to pick 0. It's between those two values. And I'm going to get a 0 plus 1 over 0 minus 4 is greater than 0. And then I get, this is going to get us a negative 1/4 is greater than 0, right? Which is not true, right? So this middle section does not work, but that would mean these outer ones do. So then that's where I'm going to shade. All right, and because this is a strict inequality, I'm going to have open circles. All right, and then writing our answer in interval notation, it's going to be from negative infinity to negative 1 with a parentheses, union from 4 to infinity. All right, and that's the essence of what we're doing in this lesson. All right, so I did number 2 first, just because number 1, there's a little bit more steps that we have to do. I just wanted to make sure you guys first understood the idea of what we're trying to do. All right, so this next one, or really the one that we should have started with, we want 0 on one side, so I'm going to subtract 1. So I get a 5 over x plus 4 minus 1 is greater than or equal to 0. All right. Now, what makes this a little bit more complicated than the one that we just did is I want the same fraction. I just want one fraction on the opposite side of the 0. So I'm going to write this 1 over 1, and then I'm going to multiply by a common denominator, which is x plus 4. All right? So this is an example of where we don't want to cancel out our denominator, right? If it was just an equal sign, like let's say I had 5 over x plus 4 equals 1, I could very simply just multiply by x plus 4 and then cancel out that, and then I get 5 equals x plus 4, right? But we don't want to do that here because it is an inequality, right? I had some people ask, why do we not cancel out the bottom here, but we do in some other cases? It's because over here it had an equal sign, and over here it has an inequality, all right? So hopefully that distinction's clear, all right? So multiplying the top and the bottom by x plus 4 is going to get us a 5 over x plus 4 minus, it's going to be 1 times x plus 4 over x plus 4. All right, and then this minus 1 I can distribute to everything on the inside over here, and then that's going to get us a 5 minus x minus 4 over the same denominator of x plus 4. And then I have a greater than or equal to 0 on the other side. I can combine like terms, so 5 minus 4 is going to get me a 1. So I have a 1 minus x over x plus 4 is greater than or equal to 0. All right, now that I have one fraction and I have 0 on the other side, I can set the top and the bottom equal to 0. So then I'm going to get 1 minus x equals 0, and I'm going to get an x plus 4 equals 0. So I get x equals negative 4 as a test point, or as a key point, and then I get x equals 1 as another one. So then I'm going to draw a number line. Negative 4 would go right here, 1 right there. And then again, I have 3 sections, so I'm going to pick 0 over here to go right in between, right? The easiest number that we can pick. And I'm going to go back to our original inequality, and I'm going to plug in 0. So I get 5 over 0 plus 4, which is 5/4, and I want that greater than or equal to 1. That is a valid statement, so that means I'm going to shade in between. And because I have with equality, I'm going to draw closed circles over here. All right. Keep in mind though, fractions, we do have restrictions, right? Do we remember what value we don't want on the bottom, right? On any fraction, I never want 0 on the bottom. So between 1 and -4, right, which one is going to make our bottom equal to 0, right? Well, that's going to be -4. If I plug in -1 into our original inequality, I get a -4 plus 4, which is 0, right? So really, I can't have a closed circle on here because I cannot include that as an answer. So I'm going to change that closed circle to an open circle. All right, so I really get an open circle at -4, even though we had a greater than or equal to. All right, so then this is going to be, right, in interval notation, parentheses, wait, hang on, let me use a different color. All right, parentheses -4, comma 1 with a bracket. All right, so that's one case where we want to change all of our open circles, our closed circles to open circles. All right. All right, so we'll try the same thing over here. Once again, I want to get 0 on the other side of my inequality symbol. All right, so I'm going to subtract by 4 on both sides. And so I get 2x minus 1 over 3x plus 4 minus 4 is less than 0. And then I can write this 4 over 1. And then I can multiply the top and the bottom by what's missing, right? It's missing a 3x plus 4. All right, and then so we're left with a 2x minus 1. I have a minus 4 times a 3x plus 4, all over a common denominator of 3x plus 4, less than 0. All right, now let's just simplify this as much as we can. I'm going to distribute that -4. I get a 2x minus 1 minus 12x minus 16 over 3x plus 4 is less than 0. And then let's just simplify this a little more. This is going to get us a negative 10x minus 17 over 3x plus 4 is less than 0. All right, so now that I have a single fraction and now that I have 0 on the other side, I can set the top and the bottom equal to 0. All right, so when I do negative 10x minus 17 equals 0, and then 3x plus 4 equals 0, I'm going to have x equals 17 over 10, and x equals negative 4 over 3. Okay, sorry, wait, this one should be negative as well, right? Negative 17 over 10. All right, if you want to avoid making the mistake that I just made, you would write out all your steps, right? Add 17 on both sides and then divide by negative 10. All right, and then I would plot these on a number line just to see where we're going to have key points. All right, negative 17 over 10 is a bigger negative number than negative 4/3, right? This is about, well, actually, this one is actually equal to negative 1.7. And then 4/3 in general is about 1.3 repeating. All right, so this is about negative 1.3. All right, so I'm going to plot negative 17 over 10 over here, and then negative 4/3 over here. All right, and then the easiest number to test is 0. So I would put 0, that's going to be bigger, so it's going to be right here. And then I would plug that into the original. So I'm going to have a 2 times 0 minus 1 over 3 times 0 plus 4. And then these zeros cancel these things out, and I get a negative 1/4 is less than 4. That is a valid solution. All right, so that means I'm going to shade this entire region. So this works, the middle one doesn't, and the one on the outside does. All right. And then because this has a strict inequality, I don't need to worry about the domain restrictions, right? Because no matter what, whether it's negative 4/3 or negative 17 over 10, right, it needs to have an open circle over it regardless, right? Because originally it was a strict inequality. So that's the difference between this and the example that we did in the previous slide, right? We don't have to check for domain restrictions because we already know that we can include that as an answer. All right, so then writing my answer in interval notation, it's going to go from negative infinity to negative 17 over 10 with a parentheses, union negative 4/3 to infinity, also with parentheses. And that would be your final answer. All right, so let's try the same thing with the next one. All right, well, let me zoom out so that you guys can see everything first. All right, so you guys, this is the entire problem. All right, so I'll try the same thing over here. All right, I want to get the 2 to the other side, and then I end up with a 6 over 5 minus 3x minus 2 is less than or equal to 0. All right, and then I would write this negative 2 over 1, and then I would multiply by the common denominator, which is 5 minus 3x. All right, and then I would get a 6 minus 2 times 5 minus 3x over my common denominator, which is 5 minus 3x, is less than or equal to 0. So I can distribute negative 2, and I get a 6 minus 10 plus 6x over 5 minus 3x is less than or equal to 0. And then simplifying this, I get a negative 4 plus 6 on the top, and then a 5 minus 3x on the bottom is less than or equal to 0. Right, so now that I have a singular fraction, I can set the top equal to 0 and the bottom. So when I do negative 4 plus 6x equals 0, right, we can add 4 to both sides. And then I get a 6x equals 4. And so we get x equals, when we simplify, 2/3. All right, so that's one of our key points. When I do 5 minus 3x equals 0, we can subtract 5, and then I get a negative 3x equals negative 5. Divide by negative 3, and I get an x equals 5/3. All right, as my other key point. So then again, I would plot these on a number line. And then 2/3 is smaller. 5/3 is bigger. And then 0 is less than both of these, right? So it would go somewhere right here. So we're testing the outer interval now, right, to the very left. I would plug this into the original. I would get a 6 over 5 minus 3 times 0 is less than or equal to 2. And then this gets us 6 over 5 is less than or equal to 2. Right, and this is a valid statement, right? Remember that 2 is the same as 10 over 5. If you want to find a common denominator, and 10 over 5 is bigger than 6 over 5. All right. So then, again, because I have closed circles, with equality, I'm going to have closed circles. And then because 0 worked, that's going to work. This middle one's not going to work, and the outer one's going to work. All right. Remember, though, with our rational inequalities, or any rational expression, I cannot have 0 on the bottom, right? We have a domain restriction. And the value of x that makes the bottom 0 is 5/3, right? When I plug in 5/3 on the bottom, I'm going to get 0, right? So x cannot be equal to 5 over 3, all right? So then I need to turn this closed circle into an open one, all right? And so really my answer is going to be in interval notation, negative infinity to 2/3 with a bracket. Union, the next one's going to have a parentheses, 5/3 comma infinity. All right, and so that's my final answer in interval notation. All right, we got a couple more slides. Sometimes they get a little bit more complex, right? But as always, I want 0 on one side of the inequality. So what I'm going to do over here is I can subtract 5 over x on both sides. And then so I end up with a negative 5 over 3x plus 2 minus a 5 over x is greater than or equal to 0. All right. Now between 3x plus 2 and x, right, they don't share any factors in common. So what I'm going to do is I'm going to write 3x plus 2 and the x as my least common denominator. All right, so that's what I'm going to need. And then so this is where I would go one by one and see what's missing in each of these fractions so that I can get them under a single fraction. All right, so this first one has the 3x plus 2, but it's missing the x. So I'm going to multiply the top and the bottom by x. So I get a minus 5x. I can do the same thing over here. This is going to be a minus 5 times 3x plus 2, right? It has the x, but it's missing the 3x plus 2. So I can multiply that on the top and on the bottom. All right, and then I can distribute negative 5, right, greater than or equal to 0. And then I get a negative 5x minus 15x minus 10 over x times 3x plus 2 is greater than or equal to 0. Right, and negative 5x minus 15x is going to get you a negative 20x. Let me just replace that now, right, just to save a little bit of writing. So I get a negative 20x minus 10 on top, and then I get 3x plus 2 on the bottom, right? And then once again, I would just set the top and the bottom equal to 0. So I get a negative 20x minus 10 equals 0, which is going to get us an x equals negative 1/2 when we fully solve that. And then for our bottom, we're going to get an x times the 3x plus 2 equals 0. And so I get x equals 0, and I get x equals negative 2/3. All right. This is also why I don't distribute that x, right? You definitely could, but then you would still have to factor it out to solve for what makes the bottom 0. All right, so it doesn't really matter if you do that or not. So then I'm going to draw my little number line. And then I'm actually going to have 3 points to plot. I'm going to have a negative 2/3, all right, negative 1/2, and 0, all right? Now, because 0 is one of our values, I can't really test that because it's not going to give me any information about my my intervals, right? So I'm going to test the next easiest thing. So let's try 1, right? I'm going to try 1. All right, and if we plug 1 into the original, I get a negative 5 over 3 times 1 plus 2 is greater than or equal to 5 over 1. And so this gets us a negative 5 over 5, which is negative 1, is greater than or equal to 5 over 1, which is 5. And that's not true. All right, so then this entire section is not going to work. The one next to it will. This one right after it won't. And the one at the very end will. Right, so now hopefully we see here, and we remember from the previous lesson that there's 4 sections here. All right, so the ones that work are going to be this one right here and this one right here. All right. And then keep in mind, we have domain restrictions on the bottom. I cannot have 0 on the bottom. I only set it equal to 0 to find out what values I'm going to plot on my number line. But we actually can't have 0 as an actual answer. So even though this has with equality, I wouldn't do closed circles everywhere, because on the bottom, if x equals 0, that's going to get us an undefined answer, and so is negative 2/3. So I'm actually going to put open circles on those. All right, but negative 1/2, we don't have restrictions on that. That's going to be a closed circle. All right, so now I'm going to write this answer in interval notation, going from negative infinity to negative 2/3, parentheses, union, this one's going to have a bracket because that one has a closed circle, comma, 0, with the parentheses since it has an open circle. And then that is our answer in interval notation. All right. And let's try the same thing over here. I'm going to get 0 on one side of my inequality. So I'm going to subtract 3 over 2x plus 1 on both sides of my inequality. And so I get a 1 over x minus 3 minus a 3 over 2x plus 1 is less than or equal to 0. All right. And then our common denominator, they don't share any factors in common. So it's going to be an x minus 3 and a 2x plus 1. All right, and then over here, what's missing, it has the x minus 3, it doesn't have the 2x plus 1. So I'm going to have 1 times 2x plus 1, and then over here, I have a minus 3 on top. It has the 2x plus 1, it doesn't have the x minus 3. So I'm going to multiply this by the x minus 3. All right, and then let's simplify this, right? Distribute the 1, distribute the negative 3. This is going to get us a 2x plus 1 minus 3x plus 9 on top. And then on the bottom, I have my common denominator, which is x minus 3 and 2x plus 1 less than or equal to 0. Simplify the top a little more. I get a negative x plus 10 over x minus 3 and 2x plus 1. is less than or equal to 0. All right, so I'm going to set the top equal to 0, and I'm going to set the bottom equal to 0. Doing this, I'm going to get a negative x plus 10 equals 0, which is going to make x equal to 10. And then on the bottom, I'm going to have an x minus 3 equals 0, and a 2x plus 1 equals 0, which is going to get me an x equals 3, and an x equals negative 1/2. All right, so I have 3 test points to use now. Drawing this on a number line, our smallest value is going to be at negative 1/2. Our next biggest one is going to be at 3, and then our largest one is going to be 10. Again, the easiest value to pick is 0, and here we're allowed to use it. So I'm going to have a 0. Plug that into the original inequality. I'm going to have a 1 over 0 minus 3 is less than or equal to 3 times 2 times 0 plus 1. And then 1 over 0 minus 3 is negative 3. It's a negative 1/3. Right, is less than or equal to 3 over 2 times 0 is 0 plus 1 is 1. So I get negative 1/3 is less than or equal to 3. That is true. So that means this entire section with the 0 is going to work. The ones right beside it are not, and the one at the very end is going to work. So I'm going to shade all where I have valid answers. All right, and because this had a less than or equal to, I'm going to have closed circles, but remember, there are 2 values here that are going to make the denominator equal to 0, right? And those are 3 and negative 1/2. So I'm really going to put open circles on those, right? So this and this. 10 is valid. It was on top, so that one does work. All right, and writing our answer in interval notation, it's going to be negative 1/2 comma 3. Union, it's going to be with a bracket over here from 10 to infinity. And this is our answer in interval notation. All right, so you can see these get a little bit tedious, and you might need to think a little bit harder as to what constitutes a valid solution or not. But you can see both of these problems combined, I'm checking right now, it took me 8 minutes to do. Right, so that's about 4 minutes per problem, right? So even though they're a little bit tedious, if you know what you're doing, they shouldn't take forever, right? All right, and so it looks like there's just one more example here. All right, so I'm going to do it the exact same way that we did the others. I'm going to get 0 on one side of my inequality. So let's subtract 3, and then I'm going to get a 2x minus 7 over x minus 5 minus 3 is less than or equal to 0. And then this minus 3 I can write over 1, and I get a common denominator of x minus 5. All right, so then this is going to give me 2x minus 7 minus 3 times x minus 5 on top, and then on the bottom I'm just going to have an x minus 5 is less than or equal to 0. All right, and I can distribute that negative 3 and simplify this fraction as much as we can. So we get a 2x minus 7 minus 3x plus 15 over x minus 5 is less than or equal to 0. All right, now simplifying this as much as we can, I get a negative x plus 8 over x minus 5 is less than or equal to 0. All right, so we have a pretty simple inequality to work with. I'm going to set the top equal to 0 and the bottom equal to 0. All right, so if I do negative x plus 8 equals 0 and x minus 5 equals 0, then I get x equals 8 and I get x equals 5, right, as my 2 key points. Right, so let me go ahead and plot those on a number line. So I'm going to have 5 and 8 right here. All right, and the easiest number to test is 0, right? 0 is going to be right here. All right, so I'm going to plug 0 into the original. I get 2 times 0 minus 7 over 0 minus 5. All right, zeros are going to cancel out, and then I get a negative 7 over negative 5, which is positive 7 over 5. And then is that less than or equal to 3? Right? Yes, it is. Right? So then I'm going to shade where 0 is, not what's next to that interval, and then again at the very end. All right, so I'm going to have shaded regions over here and here. Again, before filling in our circles, keep in mind we don't want 0 on the bottom. Right? So even though we set it equal to 0 to find our key point, I don't want 0 on the bottom. And the value that's going to make 0 on the bottom is this 5, right? If I do 5 minus 5, that gets me 0, and that's not a valid solution. So I can't have 5 as an actual answer. So I'm going to put an open circle right there, right? But everything less than 5 does work. 8 was on top, all right? So that does have a closed circle because we had a line underneath, all right? So writing this in interval notation is going to be from negative infinity to 5 with a parentheses. Union, right? We have a closed circle in 8, so it's going to be a bracket 8 to infinity. And then that's our answer in interval notation, and that wraps up this lesson. So very last lesson before your test, all right? And once again, these aren't super difficult, right? You're seeing that I took like 3 minutes on this problem, all right? But again, take your time when learning the material, but make sure that on test day, right, you know what to do per problem, right? This problem would have taken me forever if I didn't recognize that this was an inequality that I had to find the test points, right? Really didn't take crazy long, right? So the more you practice, again, this should be daily consistent practice. And with that, you should be well prepared for the test, right?